Dear my students, after discussing many things concerning about wavelengths, definitions, mathematical operations, and so and so, now let us go to examples on how we can solve or we can respond to different questions as wavelengths concern. Remember our formulas on how we can calculate wavelengths. The first question is this one here. This question is the mechanic wave, which is transverse wave moving from left to right. From this question, you have been asked to calculate wavelengths. It is very simple to calculate wavelengths. First of all, look, the x-axis is in distance. Therefore, here we can get wavelengths because wavelengths is the distance. But from different formulas, we said wavelengths is the distance between a complete cycle, which may be here, or the distance between trough and trough, or the distance between crest and crest. Now, therefore, it is you to see which one will be very simple for you to get the answer. For example, look here. At this point under crest we have 2 meter, and at this point we have 10. Therefore, the difference between this point is what make up the wavelength. Therefore, wavelength is 8 meter. We can also use trough here. This point here is 14. This point here is 60. The difference between these two is what we call wavelength. Therefore, wavelength here is also 8. Therefore, this proves that the wavelength is 8. But also, if you use scale, this is 6. Automatically, this number here could be 8 meter, which is the distance for a complete what? For a complete cycle. Therefore, this is how we can calculate wavelengths for this example number 1. Now, let us go to example 2. Let us go to example 2. Example 2 is also the mechanical wave, which is this one here. This question is most wanted. It's happened many of the exams, national exam. Even last year it came to mock exam, I remember. But also most of my students fed these questions. That's why for you, I want you to be familiar with it very, very early. Now look here. This is distance traveled by how many cycles? 1, a half, a half, a half, a half, a half. Therefore, from the point of disturbance to where the wave ends, we have how many cycles? 1, 2, 3. We have 3 cycles here. How did I say? How can we calculate wavelengths if we have the number of cycles? Remember, this distance is not distance for crest. No, it's the distance covered by a cycles. Covered by what? Cycles. How many cycles? 3 cycles. Remember, which formula is used on calculating wavelengths if we have cycles? Very simple. Wavelengths is nothing but distance covered over number of cycles. Distance equals to what? Distance equals to 10. Cycles, how many cycles do we have? 3 cycles. Therefore, what is wavelength? Wavelength is nothing but 3.3 meter. This question, my friend, is very, very important, and you'll be given 5 marks if you get this correctly. Now let us go to example number 3. Example number 3 is not a diagram, but it is just something which is given here. I don't know if you can read, or I think you can read from there. It is saying a vibrator in a LiPo tank vibrate at 5 Hz. That means that is frequency. If the distance between 10 successive crests, we have how many crests? 10, and their distance is 37.8 centimeter. Calculate wavelength. We have frequency, but I think frequency will not be used here. That this question was also asking another term, which is wave velocity, but for my case, I just pick only wavelengths. Therefore, frequency will not be used here. Frequency will be used in calculating wave velocity, where here is not our part. Now let us go direct to look. How can I calculate wavelengths if at all I have the number of successive crests, the distance between successive crests? If at all I have the distance between successive crests, the distance between successive crests, wavelengths will be nothing but x, which is the distance between this crest, over n minus 1. And we proved this one. We got it. This formula is correct. Now, what is x? The distance between 10 is the number of crest, is 37.8 centimeter. The number of crest 10 minus 1. If at all you substitute it into calculator, you will find that 37.8 you divide by 9, the answer is 4.2. Therefore, the wavelength is 4.2, but now here is in centimeter. Remember, this is how you can calculate this for this question. If at all you have the number of crests, not only crest, you can be, the question also can be asked this way. A vibrator in a repo tank vibrates at 5 Hz. If the distance between 10 successive trough, do you see? Instead of using crest, you can use trough, but still the formula is the what? Is the same. Now let us go to the last example. This example, it's happened on the last year exam, last year mock exam. This example, it comes to the last year exam. I want you to read from here, but again you join it with this one. Join it with this one here. Join it with this one here. The question was saying the successive crest and trough of a wave, the successive crest and trough of a wave are 30 centimeter apart. Find the wavelength of the wave. That means the distance between successive crest and trough. That means the distance from a crest to the followed what? Trough is 30 centimeter apart. Find. It is like here. This is crest and this is trough. Therefore, these are two successive crest and trough. Therefore, the distance from here to here, this is the trough, to here, this is 30 centimeter. Now, calculate wavelength. What did we say? If at all I have the distance between crest and trough, the distance between crest and trough, to find wavelengths is simple, because what I'm going to do, I'm going to take twice of the distance given, because for me, look here, if I want to get the wavelengths, I should have crest. Look, I should have the distance. Crest is the wavelength is from here to here. This is wavelength. But I have the distance from here to here. You see, what I have is the distance from here to here. But what I want is the distance from here to here. Therefore, there is a certain distance which is missing. Now, what is the value of this distance? What is the value of here? If I want to get the value from this point to this point, I'm going to take this value here, this value this value multiplied by 2. Therefore, it is twice of x. Wavelengths, it is twice of x. This is to say twice of x. What is x? 30 centimeter. What will be wavelengths? Wavelengths is 60 centimeter. I hope my students, you have understood those examples. Those examples will be beneficial to you when you are passing through your set 6, set 5, where now you'll be asked to find out this question of wavelengths, but also in exams. For example, this last example, it comes in the last year mock exams, where you are given the distance between crest and trough. From that distance, you are required to find what? You are required to find wavelengths. But also, some of the questions, they can be asked like this. The distance between crest and crest is 10 meter. If at all you have been given the distance between crest and crest or trough and trough is 10 meter, that is like you have been given wavelengths. Because wavelengths is the distance between crest and crest, trough and trough, compression, or rear function. See you next time. Hope you have understood. Bye.